Okay, welcome everyone. My name is Amod Onkar. I am the country head for SOLIDCAM India. We are a CAM company, and we are the gold partners for SolidWorks worldwide. We have the CAM product of SolidCAM running inside SolidWorks. So today I'm going to introduce you to SolidCAM and how we are changing the way manufacturing is done or machining is done today in India. Let me quickly get to the mission. We are here to provide every one of our customers a very powerful, complete, easy to use CAM solution with a revolutionary product called iMachining, which is changing the way machining is done worldwide. And this is completely available inside SolidWorks. So SolidWorks is our front end platform. We also have a very similar product, or probably it's the same product, but it works inside Inventor, and we call that as Inventor CAM. Same functionality. It has a look and feel of Inventor, whereas once we start working inside SolidWorks, we have got a look and feel of SolidWorks right through the entire manufacturing process. Quick word about SolidCAM. It was founded in 1984. That's like about 34 years back in Israel. We are headquartered in Israel, where we have 2 offices. It's mainly development and support operations that happen from Israel. The largest operation out of Israel is in Germany, where we have 6 offices and a staff strength of close to almost 90 people. So that's a very big operations when you consider the size of Germany. Also, we have our direct operations in the US and Canada. And in Asia, we have operations in Japan, India, and China. Affiliated companies, which basically use the name of SolidCAM but are run privately, are in France, UK, Czech Republic, and Australia, New Zealand. And we have more than 140 resellers worldwide and more than 40,000 licenses. 20,000 is slightly an old number. We have more than 40,000 licenses installed worldwide. That's a pretty good number when you consider that we are in a niche area of CAM. In Germany, we have got 6 offices spanning the Northwest, the East, South, Southwest, and the central part of Germany. We have 2,300 industrial customers and 3,800 industrial licenses. And 6,300 in educational licenses are installed. The VDW training books, which are basically the German in India, the IMTM, it's a very similar Machine Tool Manufacturers Association in Germany. It's called books are in SolidWorks and SolidCAM. So if you go to the VDW site, you will see these training books. They are there. Anybody who needs some of these training books can approach us. We'll be more than glad to provide you with that. Every office of SolidCAM is a very unique office. It just doesn't basically have computers, tables, and chairs, but it also hosts some of the most complex CNC machines ever seen. For example, our office in Germany has a NTX 1000 multi-turret multi-spindle, which costs close to about $2 million US. It's a very complex machine. It has got 12 axes, and parts like these are manufactured on such machines in a single setup. And we use these machines to test our product. We use this machine to cut parts. We use this machine to train customers. So a lot of things have been done using machines. Now, in the same establishment in Germany, we have got a Hermle C30U. It's a 5-axis milling machine. It's a high-precision 5-axis milling machine, and also a Citizen 820, which is a Swiss-type machine, which is in Indian rupees, it would cost about 1 crore. Whereas the NTX would easily touch about 2.5 crores, and the Hermle C30U will cost about 1.5 crores. In other offices worldwide, in the US, we have got Herco VM10 and VM10 UI machines, basically 3-axis and 5-axis machines at our offices at 8 different locations. We have more than 900 industrial customers and 20 staff in the US for sales and support. In Japan, we have a tech center in a city called as Gifu, where we have a Morisaki NT4250 and NV5000, which are basically highly complex mill-turn and 5-axis machines, again costing few crores. We have made this investment into every technological center in almost every country so that the customers can get the confidence of using the product straight away because they know that these products are tested on such complex machines. Our operations in India began in 2008, and we have our offices in Pune, Bangalore, Chennai, New Delhi, Ludhiana, and Ambala. These are our nerve centers where we have support and sales. Our headquarters, of course, is in Pune, and I'm speaking to you from Pune. We have more than 750 plus customers. The last count was about 780. We have 33 staff directly employed by SOLIDCAM India. It's a 100% subsidiary of SOLIDCAM Limited Israel, where we have 3 sales, 28 technical people, and 2 people into documentation. We grow at an average of 20% every year, and we are a de facto standard in multi-turret, multi-spindle machining. That's a pretty complex area of machining. Our customer domains are across aerospace, power, oil and gas, general engineering, and die mold in that order. Today, our customers are like 40% in aerospace, about 15% in oil and gas, about 10% to 15% in power, about 5% in die mold, and the remaining in general engineering. And that's how we are. We are today almost number 1 in aerospace when it comes to aerospace machining. Every alternative machine shop in Bangalore and Chennai has SOLIDCAM. So that's how popular we are in the south. In the north, we are very popular with the general engineering and medical industry, where we are very strong. And it's almost equivalent that every alternate machine shop has heard about SOLIDCAM or will be having SOLIDCAM at their end. SimData is an NC software and related services market assessment company. They come up with reports every year about different CAD/CAM companies worldwide. And they named SOLIDCAM as the fastest growing CAM vendor worldwide out of the last 5 out of the last 8 years. If you take the reports of the last 8 years, 5 years, SOLIDCAM has been consistently growing at almost about 40% every year. The major benefits, first of all, working with SOLIDCAM inside SOLIDWORKS is the same look and feel, or single window integration, what we call it as. The entire feel of working in SOLIDCAM is as if you're working with SOLIDWORKS functionalities. So that's how nicely it's integrated inside SOLIDWORKS. Full associativity, which means the toolpath automatically updates when the SOLIDWORKS model changes. SOLIDCAM works in the assembly environment of SOLIDWORKS, which allows you to define fixtures, tooling, and vices, and carry all of these together with you for the machining process. I'm more than 10 years as a gold partner to SOLIDWORKS, so it's a pretty long journey with SOLIDWORKS, and we have this gold certification program that we have every year, and SOLIDCAM gets through it. We get a badge saying that we are a certified gold partner, which basically means we have one of the tightest integrations of an external product inside SOLIDWORKS. The benefits of working inside SOLIDWORKS is that, first of all, you have got a single window integration. That means every functionality that we have with SOLIDWORKS is carried over into SOLIDCAM. So you have the same look and feel, easy to learn, easy to use. If you learn SOLIDWORKS, 60% of SOLIDCAM is already done. 40% is the process that you need to only learn. Since SOLIDCAM works directly inside the SOLIDWORKS parts and assemblies, additional information like dimensions and tolerances are also available. There's absolutely no data translation, no conversion errors, and no missing data. That's how it happens. And because we are working with SolidWorks, we support more than 18 formats that can be directly imported inside SolidWorks, like Direct Pro Engineer, Direct NX, Direct Inventor, Direct Solid Edge. If you're working with the professional and premium versions of SolidWorks, you could directly import CATIA. If you're having a native SolidWorks standard format, then you can also import IGS, STEP, ACES, Parasolid, and so on. So about 18 formats plus 4 or 5 direct. So about 20, 25 formats can be directly imported inside SolidWorks. This is very good for people who do job shops because they get data from different parts of their customers. It comes in different formats. When I said complete integrated manufacturing solution, this is what I meant. We have got machining solutions from 2.5D milling, high-speed surfacing, 3D HSM and HSR. This is for die mold and complex aerospace parts. Indexial machining for multi-setup machining. Simultaneous 5-axis machining with application-based support for impellers, for port machining, for swarfing, for screw machining, and so on. They are standard functionalities. We've got turning and mill turn. We support up to 16 axis today. We support 16 axis completely. Wire EDM and also solid probe. What I did not explain to you was the first 2 modules, which are basically the game changers for SolidCAM, the iMachining 2D and iMachining 3D. So we're going to see a bit more about both these products. So we have got what we call as a revolutionary iMachining functionality, which provides a time savings of almost 70% and more on machining. So if your customer is cutting metal, he's cutting a lot of material, he's scooping out a lot of material, and let's assume that he takes an hour to cut a part, the same thing can be done inside SolidCAM in under 15 minutes using iMachining. So iMachining is nothing but a high-performance milling system which takes into account the tool, the material to be cut, because it needs to understand the physical properties of the material. It needs to understand what geometry you're cutting, and it also needs to understand the machine that you're cutting on. Basically, it needs to know the RPM, the feed rate, the spindle construction, the power available. All those things it captures from the machine and then generates an envelope of cutting conditions, which will automatically calculate the strategy, the depth of cut, the actual side step, the feed rate, the spindle speed, all those things, and generate a program that will reduce the cycle time by almost 70%. So iMachining 2D basically is a revolution in CNC machining. Increased productivity due to shorter cycles, dramatically increased tool life, especially if you're using smaller tools, then the tool life dramatically goes up. We machine parts up to 90 HRC using iMachining. 90 HRC is nothing but your cutting tool material, which is basically tungsten carbide. iMachining is also available in 4-axis and mill turn. Very high programming productivity. About 4 steps are needed only to define the entire process, and that's it. You get the program straight away from iMachining in just 4 steps. Shortest learning curve. Just 1 day's training is enough for people who have absolutely no experience in machining to jump up to iMachining and generate programs like a professional. I will now move forward because I'll just jump these slides. And what basically iMachining does is that it needs to know the material and the machine. So when I define a material, I need to define, or I need to tell to iMachining that I have a material XYZ which has got an ultimate tensile strength of so many Newton per mm square. For example, if I take aluminum, then the grade of aluminum, let's say 6061, the aerospace grade, then the ultimate tensile strength of this material is about 460 Newton per mm square. So this is what I need to tell to iMachining, that I have a material which has got a tensile strength or UTS value of 460 Newton per mm square. I also have to define a machine. Let's say I have a machine of BFW. So I need to define what is the maximum RPM available on the spindle. What is the maximum cutting feed rate this machine can travel? What is the spindle construction? Is it a direct spindle? Is it a belt-driven spindle, or it's a gear-driven spindle? And what is the power available on the spindle? So once I define these 4 parameters and the material, it creates a database of this machine and the material. And then it will ask me, what is the geometry that you would like to cut? So I just define that I want to cut a pocket, a rectangular pocket. And then it'll ask me, how much depth do you want to go? So I define the depth. Once I define this and pick the tool, iMachining then calculates everything on its own. This is a very complex calculation, and none of our competitors are near to where we are, even by a few hundred miles. This is extremely complex calculations, and it comes up with something unimaginable by even the best of the cutting tool standards. And the best part is that the program runs on the machine on the very first attempt. You don't need to do any kind of dry cutting or nothing. And it's unbelievable. People don't believe it for the first time. They have to keep running it 1, 2, 3, 4 times to let that feeling sink into them, that machine and material and the tool could behave in a different way than what we imagined. Okay. We've got a lot of customers based on different domains. For example, in the oil and gas valve customers, we've got G Dresser Valves, Coimbatore, Flowserve India in Bangalore, Botil Oil Tools in Manesar, Sarasi India, Dehradun, Windlass Dehradun, Praveen Industries New Delhi, Pressy Hole Thane, Crane Process Systems Satara. And with different machine tool vendors also, we have got customers. I've just noted down few of them, can't put all the 750 out here. So we have got with the complex machines from Mazak, like the I400, I300, I200, these are basically Integrex machines. They are like 8-axis, 9-axis Milton machines. And we also have customers also using the Deckel Maho or Deckel Morisaki machines, like Sandvik, KTS Spindle Tooling Pune, Sim Tools Bangalore, and Mac Aero Bangalore. So there are quite a lot of these customers using different complex machines and SolidCAM. Some of the successes I would like to present here. And basically, this was one of the first successes that we had with iMachining, where we were cutting titanium. Titanium is one of the toughest materials that you can get to cut, and this material is mostly used in aerospace. It's also used in medical industry. Their existing cycle time using CATIA was 14 minutes, whereas with iMachining on the very first attempt, it was 3.5 minutes. Burns Machinery in the US, the material was Inconel, again a very tough material to cut. Machining time saving was about 75%, tool life up by 300%. Again, an oil and gas company, material was Inconel, time savings about 86%. Roop Polymers in Manesar, this was our very first success in India with iMachining. EN31 40 HRC, and their existing cycle time of 360 minutes was brought down to 100 minutes by iMachining. Total cycle time down from 2040 minutes down to 1380 minutes by SolidCAM. Indo-US Bangalore, A2 mold steel on a Makino S33 high-speed milling machine. Their existing roughing cycle time from 180 minutes down to 32 minutes, 82% cycle time savings. Same company wanted to cut copper, so we did that on the Makino S33 again, 23 minutes down to 3 minutes. Maini Aerospace, one of our largest customers in India, on an aluminum 7075, Existing cycle time of 200 minutes, completed part in 84 minutes with iMachining. Ducombe Bangalore, magnesium H24, one of the highly combustible materials. If you go wrong with your parameters, it can catch fire. 480 minutes down to 170 minutes. Ravila Precision, they make turrets for LMW. On a TAL VM500, their existing cycle time was brought down from 240 minutes to 47 minutes. Pressy Hole, this was done on a very old machine, a 20-year-old Morisaki retrofitted on a stainless steel P660. Their existing cycle time of 150 minutes down to 22 minutes. Maruti Suzuki Powertrain Division on an H1348 HRC material. Overall cycle time from 260 minutes down to 108 minutes, 58% savings in cycle time. And the best part, material tungsten carbide. Our competitor cut the part in 42 hours. iMachining, very first attempt was 54 minutes. So you can see the amount of savings iMachining gets in when it is encountered with a challenging situation. Tough material, small tool, not so rigid work holding conditions, iMachining comes up the winner. Other than iMachining, we also have 2.5D milling, which is powerful and easy to use. You have full control over the entire toolpath, including feature recognition. We've got automatic drill and pocket recognition and machining, supports special thread milling operation. We have got direct integration with a company which is a world famous company for thread milling tools. It's called Wardex. And also another company that's it's called Carmex. We have got direct integration with these two companies. The G code generated includes full compensation, subroutines, M codes, and we can also create parametric post processors. SolidCam HSS, it's for high-speed surface machining, and it's a very good module to support 2.5D machining for machining localized surfaces. We've got advanced gouge control for holder, arbor, and tools, supports standard and shaped tools, and machines undercuts very easily. SolidCam HSR and HSM basically is a module that is meant for die and mold applications, where you can cut extremely complex dies and molds very easily using all the functionalities given in HSR and HSM, where we have about 15 different types of finishing strategies, about 5 different types of roughing and rest roughing strategies, unique machining and linking strategies for generating high-speed toolpaths, no sharp corners, no sharp motions. Industrial machining is for machining parts where you would like to cut it from different sides, or you would like to mount what you see here on your right-hand side, what we call in the machining language as a tombstone, where patterns of parts are mounted and you can machine the parts from different directions like an array. One part could be done 16 times, so you get 16 times the productivity, so that once you mount 16 parts, you get the finished 16 parts altogether. No need to mount and remount again. iMachining 3D is a upscale for iMachining 2D, which we just saw. This is meant for, again, a die mold application where roughing is done using an end mill, and the technology of iMachining is applied to iMachining 3D. Simultaneous 5-axis, it's very powerful, and we have got toolpath strategies to machine any kind of part in the world. There's nothing that cannot be done with SolidCam 5-axis. We also have specific application solutions for swarf, multi-blade, port, 5-axis debarring, multi-axis drilling, and conversion of 3-axis to 5-axis toolpaths. You can simulate the whole machine tool, showing the motion of all the rotational and linear axis. You have mill turn, which is very complex, and it's been done very easily inside SolidCam, where you can handle multi-turret, multi-spindle milling and mill turn machines. You can use iMachining inside mill turn. You can do machine control operations, and you can visualize the entire machining on the machine as if it is happening on the machine inside the software. So you could simulate the entire machine itself. And then you have a probe. We have SolidCam probe, which is used for defining the home positions and also for checking parts on the machine itself before they are unloaded. Because sometimes you could miss off a feature and then reloading the part back onto the machine and centering it and getting the home position becomes very difficult. Instead of that, you spend about 2 or 3 minutes and check the part on few of these features and make yourself sure that you have machined everything and then unload the part. A very useful module inside SolidCam. So if you look at some of our international customers, we have got customers in different domains of automotive, aerospace and shipbuilding, mold and die, medical, consumer, electronics, mechanical manufacturing, military, optics, and education. So we've got quite a large spectrum of customers, which you can see on your screen. So these SolidWorks and SolidCam are today the best integrated CAD/CAM systems, where you have got the best CAD system of SolidWorks and the best CAM system working inside SolidWorks called SolidCam. Together, they are a pretty solid choice. So let's just look at how the software looks like. For example, I'm now in my software. I'm inside SolidCam, and you can see that I'm using all the functionalities of SolidWorks. Wherever I am, it doesn't matter what I'm doing, I'm always inside SolidWorks. For example, if I would like to edit this part, so I can right-click on this, click on Edit Part, and you'll see that all my functionalities, all my SolidWorks CAD functionalities are available to me without even having to close the window, go out, open something else, do the work, and come back. For example, I would like to insert another hole here. So I'll go to the sketch, top view, make another feature here, and this is 2R. And if I want to provide a dimension with reference to, let's say, one of these edges, so I can do that. This is 10 millimeters. And from here to this edge, this is about 30. It's done, and I'll extrude that one through all, and I'm done. I have the hole ready. I can come out of the SolidWorks part, and I'm back into my machining module. For example, now I would like to do some drilling operations. So I can right-click on the operations here and apply drilling and the 2D drilling, and I can pick all the faces. I just pick the face, okay. I pick this face, and you can see that I've picked almost all of the holes that are available to me. And I pick the tool that I would like to use for drilling. So it's a 6 diameter. I would like to go with a 4 diameter first. Provide a holder. Since I'm using an HSK, I would like to use a shrink fit holder of 6. So if I open the tool, now any changes that I make to the tool are automatically reflected in my image here, so I can get a visual feedback of what is happening. I'll accept it, pick the levels. Now I'm saying that the levels are automatic and the drill depth is about 10 millimeters. The cycle that I'm going to use, because I'm using a Heidenhain post processor, I'll use the pecking cycle, and the release distance, though my release distance is 1. Step down every time is 5 millimeters, and that's it. Let's calculate. Okay, you can see that my drilling programs are done. I can change this to a more familiar control of FANUC. Okay. So I'll go to the last operation and calculate this. Put it up. Let's calculate this. And if I generate the G code, and this is how my G code will look like. So this is basically a simple FANUC example that I took up, generated the part program, and here is the output coming out from the part program. Okay. So we have got drilling, we have got facing operation, and we have got contouring. So if I calculate this, I can do the external contouring. So if I run the simulation, if I go to Solid Verify, you can see that since I've used the assembly environment, I can now mount my fixtures onto the stock and use them to determine if there is any collision between the tool and the fixture. And this is how my machining will happen. Okay. So simulation is also directly available. Now, what I can do is I can change again to a different machine so that you can also see the machine simulation, what we have defined inside SolidCam. So I'm going to use a DMG 50 monoblock, and I just need to put some values here from here to the bottom. That's about 120 millimeters. So let's add in the setup. Okay, it's already done. Say okay. I will calculate all the operations. Yes, please. So that's how quickly the operations are calculated. And if I go into the simulation and to the machine simulation, you'll see that we load the entire machine from the CAD, and we are now ready for our simulation. So we have got a DMU5 axis ready for our simulation, and we can start the simulation. You can see the material removal right inside SolidWorks. We did not close any of the trees or any of the windows, and now we are doing the external cutting. We finished drilling. Okay, now the upper part is being done. You can zoom, you can increase the speed at any given point of time. Okay, that's how the part is completed now. It's now waiting for me to exit. Okay, so we've got a complete machine simulation that's built in inside SolidCam. So you can simulate whether it's milling, turning, or any kind of an operation. So let's look at now some of the 3D operations. So let's open another part. Let's open this one. Okay. So we already have a roughing operation designed here, which I'm going to edit this, which is nothing but a 3D operation. So I'm going to specify central, a simple 3D operation. Okay, that's done. Once this is done, I can run the simulation again. And this is a 3D roughing, basically, for a mold. So it generates a roughed out part, which I can use now for my finishing operation. So you have got several finishing operations. So if I go to 3D HSM, we've got constant Z machining, So I can pick a tool. Let's pick an 8 diameter ball nose. Ball offset. Let's say our step down is 5, but I would like to machine from a range of an angle from 45 to 90 degrees. And it's a bidirectional machining, and we can just hit the calculate button. Okay, so we have done our machining of Z levels at a particular angle. I can run the save and copy this operation, paste it, edit using and generate it to a linear. Since we did from 0 to 45, 45 to 90, my next operation is going to be from 0 to 48, and I'll machine it at 45 degrees. Let's hit this calculate button. Okay, you can see that now we've machined completely using linear and also the constant Z. So we combined both of these strategies together to get the final result. So if you look at what we can offer in 3D, we have got so many different types of finishing options, along with about 4 or 5 different roughing and rest roughing operations, where we can handle a spectrum of parts, right, ranging from a simple mold and die to a complex mold and die part, castings, patterns, aerospace components, etc. I'll quickly also run you through one 5-axis part so that you get the feel of what we offer. So let's open the impeller part. Okay, so you have parts like these that you can easily machine inside SolidCam, where you can generate a roughing toolpath straight away just by defining the geometry as an impeller geometry. And you could also do the finishing of blades, okay, finishing of the fillets, finishing of the smaller fillets, and also finishing of the hub. So if I run the machine simulation, let me change the machine to the DMU50. Okay, continue. Let's calculate one of the parts so that I can show the simulation. Okay, so if I go into the setup, we've already put the setup. Let's run the simulation, machine simulation. That's okay. Okay, so this is the show the workpiece, so you can see the machine and the part and the fixture. And if I run the simulation, I plot. This is how my simulation will look like. So it's the full 5-axis simulation that you can actually see on the machine. Whatever is exactly going to happen on the machine is being simulated right on the screen itself. Okay. So as you can see, SolidCAM is actually providing you the entire spectrum for generating machining programs, whether it's for milling, whether it's for turning, whether it's for mill turn, whether it's for wire EDM, everything sitting inside SolidWorks. So all you need to do is to have a license of SolidWorks. Your customer needs to have a license of SolidWorks, and we can provide SolidCAM. And in event the customer doesn't have a license of SolidWorks, then we can provide what we call as an embedded bundle of SolidCAM, which also comes with a license of SolidWorks. Basically, they have to choose the flavor of SolidWorks, and we can supply that flavor of SolidWorks bundled with SolidCAM. We call that as an embedded system. And the entire support is basically handled directly by SolidCAM. So if there's a reseller, then the reseller only does the front-end sales. That's done by the reseller. We handle the entire support because we have a pretty large and a capable team of engineers who can support this product. All right, I think it was a pretty good session for about 55 minutes and good enough to get kickstarted. You can get my details from Manas or from Shamtiku, their institute. We have a very close working relationship with them. They are our training partners, and so you could become one of our training partners for SolidCAM. So any questions, any information that you need from us, please feel free to write to me or call me, text me, anything, and I'll be more than happy to respond to you back. Thank you very much.
Thank you so much, sir.
Thank you.
Thank you, Mr. Amod.
Thank you, sir.
Introductory part.
ഇപ്പൊ ആവേ അവനെ എനിക്ക് തോന്നുന്നു വന്നോണ്ടിരിക്കാൻ തോന്നുന്നു വിളിച്ചിട്ടെടുക്കുന്നില്ല ഫോൺ എന്തായാലും നിക്ക് അവൻ വന്നിടുന്നുണ്ടെങ്കിൽ ഞാൻ ഒന്നുകൂടെ നോക്കട്ടെ ആ ശരി എന്നാ വന്നോ അവൻ നോക്കി